Hi everyone, welcome back. So today we're going to be talking about simplifying quadratic expressions by completing the square. So the first thing we're going to do here is we're actually going to remind ourselves what it means to complete the square. And we're going to do that by solving quadratic equations using that method. So if we remember, when we solve using complete the square, we're going to half square and then add this b with this b value. And I'm just going to put b in parentheses. All right, so we're going to half square and add using that b value that's in our equation. This is how we solve quadratic equations by completing the square. So taking a look at number 1, we have 12 equals x squared plus 6x. This is actually the perfect way we want our setup to be when we complete the square. We remove that c value, that constant that was originally there, because we want to replace it with a perfect square. In order to make, at least in number 1, we want to make the right side of our equal sign a perfect square trinomial, because when we do that, we are able to factor it very, very easily. So let's get started. So working with number 1 in the form that it is, I see that I have a b value of 6. Okay, so b equals 6. I'm going to half it, so half of 6 is 3. I'm going to square that to get 9. And now I'm going to use that 9 to help me rewrite my equation here. So remember, this 9 is the value that we're adding to both sides, not just one, but both. And the reason we add it to both is because this is an equality property. Whatever we do to one side, we have to make sure that we do to the other side. We're not trying to change the original quadratic. We're just rewriting it a little differently. So continuing on here, I'm going to take the right side of my equation and I'm going to factor it. So I need to find numbers that multiply to 9 that add up to positive 6. So I know that positive 3 times positive 3 gives me 9, and positive 3 plus positive 3 gives me 6. All right, looking good so far. Now I'm going to rewrite the right side of my equation as x plus 3 squared. To solve, I'm going to square root both sides, because I have to undo this squared term here by square rooting. Now I can't simplify the square root of 21. There are no factors of 21 that are perfect squares, so I'm going to leave this as plus or minus the square root of 21 equal to x plus 3. And to finish this, to get x all by itself, I subtract 3 from both sides, and when I do that, I get negative 3 plus or minus the square root of 21. And this is how we solved for x in question number 1. Looking at question number 2, I noticed that 4 in front of my x squared. Now I need to get rid of that 4. You can either factor it out on the left side, or using an equality property, we can actually divide every term on both sides of the equal sign by that 4 to make it disappear altogether. Now 94 divided by 4 is not going to give us something really nice. It's going to give us 23.5, but that's okay. We can still work with it. And then 0 divided by 4 gives us 0. All right, so completing the square. I'm going to bring this 23.5 to the other side through subtraction. Again, an equality property. So I'm left with x squared minus 10x. I'm going to say plus blank because I'm going to get a new c value here that's going to make that left side a perfect square trinomial. And that's going to be equal to negative 23.5 plus, and I'm going to put that same value on the other side because whatever I do to one side, I have to do to the other. This is an equality property. All right, so what is that value? What am I going to be putting in that space? Well, I have a b value, of negative 10. I'm going to half it. I think I wrote positive 10. There we go, negative. Half of negative 10 is negative 5. Yoink. and square it, and we get 25. So placing that 25 in the space provided, now I'm going to factor the left side. So something to remember, and I'm not sure if you guys, we talked about this briefly, I know in my class, so Mrs. Hayward's class, I'm not 100% sure. Remember, this number right here, so when we took half of b, that actually ended up telling us what our factor was going to be inside our parentheses as well. And you can see that in question 1. Notice how 3 and 3 match up. -5, if we were to factor this, -5 times -5 gives us positive 25, -5 plus -5 gives us -10. So when we take half of b, that actually ends up being the factor that goes inside our parentheses. So just a little trick for you. All right, so simplifying the right side, I get -1.5. Okay, so continuing on to solve, I square root. And again, whatever I do to one side, I have to do to both. The square root undoes my square term, leaving me with just x minus 5 here, equal to, now if I take the square root of 1.5, I come up with something really long and yucky. So I'm just going to leave this as the square root of 1.5. Oop, and I think I put negative when that should be positive. I bet you guys were yelling at me through the computer, weren't you? There we go. I know my folks were. Okay. Alrighty, so we're going to leave this as just plus or minus the square root of 1.5. I'm going to add 5 to both sides. And when I do that, I get 5 plus or minus the square root of 1.5. There we go. All right, so solving away, let's move on to number 3. All right, so number 3, that 1/2 is great, but I've got to make it go away in front of that r squared. Now I can go ahead and divide. I can use an equality property here. I can divide every single term by 1/2, or dividing by a fraction, remember, is the same as multiplying by its reciprocal. So I can also multiply every term, so whatever way you look at this, I can also multiply every term by 2. So that will make just r squared minus 12r, and just to fill this in, plus blank, equals 2 times 2 is 4, plus blank. All right, so our b value is -12, so b is -12. I'm going to half it, and I'm going to square it. And now I'm going to take this 36 and I'm going to add it to both sides. Now remember, using that trick that we figured out earlier, this -6 should be the factor inside my parentheses when I factor this left side. So let's go ahead and make sure that it is. Alrighty, so looking at the left side here, I need factors of 36 that add up to -12. -6 and -6, make that happen. And I'm just going to skip a step and I'm going to say r minus 6 squared is equal to 40. Now when I square root both sides, my left side, my square root undoes my squared term, leaving me with r minus 6. The square root of 40, I can simplify. I can break this apart into square root of 10 and square root of 4. And notice the square root of 4 gives me 2. And I can't forget, plus or minus. All right, bringing that 6 over through addition, I get r equals 6 plus or minus 2 root 10. Now be careful, make sure you don't combine the 6 and the 2. These are not like terms. 6 and 2 root 10 are not like terms, so we cannot combine them. We're going to leave them separate. All right, last but not least, looking at number 4, this almost looks like standard form for a quadratic, except we're just missing an a value, but that's okay. Let's still work with this even though we don't have any true numbers that we're going to be dealing with. So if I treat this just like any other complete the square problem, I get rid of that c. I'm going to say plus blank equals -c plus blank. All right, what are we filling in that blank? Well, our b value is b. Dividing that by 2 would be b over 2. And squaring that, so b over 2 squared gives me b squared over 4, right? Square the numerator, square the denominator. All right, so I am going to add b squared over 4 on both sides. Okay. Now when I factor the left side, again, remember, whatever our b value is cut in half is technically what our factor is inside the parentheses. So this is going to be rewritten as x plus b over 2 squared. Now my right side, I'm going to simplify this a little bit. I want to get common denominators here. So if I want to get a 4 underneath c, then I have to make sure I actually multiply this numerator by 4 as well. So that's going to give me a negative 4c over 4. Now I'm going to rewrite this too. I'm going to kind of switch around the order a little bit here. So I'm going to put b squared minus 4c. So notice how I just switched the order. The negative 4c remained negative and the b squared remained positive. And now I'm going to put that over 4. Okay. All right, square root. So square rooting both sides, square root undoes my squared term, leaving me with x plus b over 2. Now when I square root this side's going to be really interesting. So if I treat it as square rooting the numerator followed by square rooting the denominator, not a lot of changes can happen in the numerator, actually none. So the numerator stays the square root of b squared minus 4c. But my denominator, when I square root that, I get 2. This is starting to look familiar. All right, subtract this b over 2 to the other side, because remember, when we're solving, our ultimate goal is to get x all by itself. And now I'm left with x equals negative b over 2 plus or minus the square root of b squared minus 4c over 2. Very interesting. This looks familiar. Any guesses? Well, if you guessed the quadratic formula, you're absolutely correct. So if our a value was there, you know exactly where it would have shown up. It would have been in our denominator. It also would have been right here in between the 4 and the c. So here's how we actually derive the quadratic formula by completing the square. All right, let's get to today's stuff. So now we are going to still be working with this complete the square method, but we're going to be working with it a little differently. Instead of using complete the square on an equation or with an equation, we're going to be completing the square with a quadratic expression. So when I say that, I mean we're going to simplify. We're not actually going to be solving for an x value here. We're going to be simplifying a quadratic equation or a quadratic expression, using the complete the square method. So remember, when we simplify, we're basically rewriting our original quadratic in a different form. So for example, when we factor, so factoring is a way for us to simplify, if you will, a quadratic. So factoring, if we're looking at r squared plus 4r plus 3, to factor this, I'm going to use trinomial factoring where a is 1. I'm going to find values that multiply to 3 and add to 4. Okay, well that's easy enough. 3 and 1. Positive 3, positive 1. So this is how we simplified our original quadratic by factoring. To simplify a quadratic by completing the square, I'm going to follow a very similar method from above, but we're never going to cross an equal sign here. So that's one thing that we really have to make sure we keep in mind. And the reason we're never going to cross one is because an equal sign doesn't exist. So here, To kind of separate or to pull out what I want to use for my perfect square trinomial, I'm going to take r squared and plus 4r, and I'm going to put that in parentheses, and I'm going to say plus blank. So kind of like I did before, instead of moving this positive 3 over to another side, instead what I'm basically going to do is I'm going to move it outside the parentheses. Okay, so I'm not moving it over an equal sign here. It's staying on the same side as my other terms. Now, having said that, if I'm adding this new value inside my parentheses to make sure that I keep the original quadratic, so I still want to make sure that I'm working with this original quadratic, I'm going to actually subtract whatever value I put in as my new c. And the reason for that is I want to make sure I keep my original quadratic. If I add it on the inside, I need to subtract it on the outside. That way, to be perfectly honest, those two values cancel out, giving me r squared plus 4r plus 3 once again. So to figure out what value is going to go there, I'm going to take my b, I'm going to half it, and I'm going to square it. So it looks like a 4. Now, remember, if I were to simplify this the way it looks right now, this plus 4 and minus 4 would cancel out and I would be right back to where I started. That's the reason we added on the inside, subtracted on the outside this time. Alrighty, so now just doing what I did before, I'm going to factor what's inside my parentheses. So I know 2 times 2 gives me 4, 2 plus 2 gives me 4. So when I factor this, I get r plus 2 times r plus 2. And here I'm going to simplify the plus 3 minus 4 to give me a minus 1. Now my last and final step, I am going to take this r plus 2 times r plus 2 and I'm going to rewrite it as r plus 2 squared minus 1. This is what we call the simplified form of a quadratic using the complete the square method. So here's where we're going to try and get to each and every time with our problems on the next page. So let's take a look at number 1 and let's do some practicing here. So again, we're not solving, we're simply trying to simplify our quadratics using the complete the square method. So to start, I'm going to take my first two terms, a squared minus 4a, I'm going to put them in parentheses, plus blank. I'm going to take this plus 15, move it on the outside, and then I'm going to say minus blank. Okay, so I need to come up with that new c value that's going to make what's inside parentheses a perfect square trinomial. So I'm going to take my b value of negative 4, I'm going to half it, and I'm going to square it. So 4 is what I'm going to add and subtract in my problem. All right, looking at what's inside the parentheses, I'm going to factor. So factors of 4 that add up to negative 4, easy enough, a minus 2. And remember, same rule applies. When we half b, what we get when we take half of b is going to be the number that's inside our parentheses. Simplifying what's on the outside, 15 minus 4 gives me 11. Here is our final answer. Okay, so again, we're just simplifying. We are not trying to solve for our variables here. We're not trying to find a value of a or n or anything like that. We are just rewriting the original quadratic in a different form. Okay, so let's take a look at number 2. So number 2, first thing, take n squared minus 2n, put them in parentheses, plus blank. Take that minus 15 on the outside, and we're going to subtract whatever we put in that blank. All right, so our b value is negative 2. Half it. Square it. And we end up with 1. Okay. Alrighty, so factoring, again, use that value that you got when you took half of b, so n minus 1 squared, and then minus 16 on the outside, and you are all set. Okay, moving down. Taking a look at number 3, again, take those first two terms, c squared plus 20c, put them in parentheses with a plus blank, minus 40, minus blank. All right, so looking at this value, 20 cut in half is 10, squared is 100. So I'm going to add and subtract 100 in my problem. Factoring 20 divided by 2 gives me 10, so we're going to have c plus 10 squared minus 140. Now if you want to write this all out, so if you wanted to say c plus 10 times c plus 10 minus 140, you can absolutely do that. That is totally fine. Okay, taking a look at number 4, x squared, remember this is going to go inside the parentheses, minus 1000x plus blank gives me, or I should say, plus 60,000 minus whatever that blank's going to be. Oh boy, this is going to be a big number here. All right, so take our b value of negative 1,000, divide it by 2 is going to be negative 500 squared, so negative 500 squared is 250,000. Oh boy, I need a bigger blank here. Okay, so 250,000. There we go. Factoring, so remember, take your b value, cut it in half. That's going to be the value that goes inside our parentheses. So if you want to write this whole thing out, you could say x minus 500 times x minus 500. And this is going to give us minus 190,000. And just rewriting the x minus 500 times x minus 500, we would say x minus 500 squared. Okay, and here is how we simplify that original quadratic using complete the square. All right, now number 5 we have to be a little careful with, and the reason for that is we have this a value of 1/2. Now, since we don't have an equal sign, we can't just divide every term by 1/2 to make it completely go away. We cannot apply an inequality property because we don't have an equal sign to do that. So instead, what we are able to do though is we are able to factor out a 1/2 using GCF factoring. So when we factor, which is not an equality property, so it's okay for us to do that only on one side, I'm going to divide each term, sorry, I don't know what happened there. I'm going to divide each term by 1/2, and when I do that, remember the 1/2 comes in front. And now inside my parentheses, I end up with b squared. So negative 4 divided by 1/2, remember dividing by a fraction is the same as multiplying by its reciprocal. So negative 4 times 2/1 is negative 8. And then 13 divided by 1/2, same thing, 13 times 2 is going to give me plus 26. Alrighty, so now we're going to keep working. We are going to complete the square on everything that's inside the parentheses, but I want to exclude the 1/2 for now. I'm going to keep this guy on the outside for a second here. Now, in order for me to really exclude the 1/2, I'm going to put up a bracket here just to separate what's inside parentheses to what's outside parentheses to that 1/2. So now I'm going to start completing the square kind of like I did before. Inside the parentheses goes the b squared minus 8b plus blank. Outside the parentheses is the plus 26 minus blank. And then all of that is inside the bracket. All that takes place inside the bracket with the poor 1/2 on the outside. Alrighty, so what are we filling in that blank? Well, half of negative 8 is negative 4. Negative 4 squared is 16. All right, so b squared minus 8b plus 16. Oh, hang on. Actually, let's do this. Sorry. There we go. Okay. Alrighty, so b minus 4, squared. So this is just me factoring now what's inside the parentheses. Remember, half of b, that negative 4 is what's going to go inside our parentheses here, which makes sense because negative 4 times negative 4 gives me positive 16. When you add those together, you get negative 8. And on the outside is going to be plus 10. Okay, so to make this look a little bit nicer, I am going to actually try and get rid of these brackets. Now, in order for me to get rid of these brackets, I have to distribute this 1/2 through to both terms. And I say both because there are only two terms. b minus 4 squared is all one term. So when I distribute this 1/2 to it, that 1/2 must stay on the outside. It can't touch anything inside the parentheses because we first need to take what's inside the parentheses and square it, raise it to the power of 2. And if you think of PEMDAS, order of operations, parentheses followed by exponents, then we move on to multiplication. So that 1/2 is going to sit outside the parentheses for now. 1/2 times 10, we can do that. 1/2 times 10 gives us 5. And now we have simplified that original quadratic. So that one we just had that extra step because of that a value. All right, last but not least, let's look at number 6. Number 6, we go back to an a value of 1, which makes life a little bit easier. So k squared plus 7k plus blank. Move that 6 to the outside, and now I'm going to subtract that blank from it. All right, so half of 7 is 3.5. 3.5 squared is 12.25. Whoopsies, sorry about that. All right. Here's where remembering again that half of b is our factor, because in these cases we've never really factored when we've had a decimal. So remembering that when we take half of b, that's what goes inside my parentheses comes in handy. So half of b would be 3.5, so that's going to be k plus 3.5 times k plus 3.5 minus 6.25. So some of these I'm doing the long version, some of them I'm doing the short version. Okay, I just want to make sure you guys are seeing and understanding what's going on here. And there's our final simplified version using the complete the square method.